Hey guys, I just wanted to run through a little bit of section 3.6 to kind of talk about it. So a little bit of vocabulary. First, we have what's called a relation. That's just a set of ordered pairs or a point. Then we have two very important words, domain and range. Domain is your x coordinates and range is the y coordinates. So what I've done is given an example first. This right here is called a relation. So that's just a set of ordered pairs. And we want to find the domain and the range. So if we look at the domain first, that's your x coordinates. So we have 0, 3, -1, and 3. So I've put them in numerical order here, -1, 0, and 3. You don't have to, the order doesn't matter. But you do notice that even though there was 2 3s, we only wrote it once, so you don't have to repeat them. And then we also look at the range, which is your y's. So that's 2, 3, 0, and -2. And so you can see I put those there. Again, I put them in numerical order. You do not have to do that. Okay, the next thing in section 3.6 talks about functions. So a function is a set of ordered pairs that assigns one y value to each x value. The easier way to remember that is always just that an ordered pair can't have, sorry, a function can't have two ordered pairs that have the same x but different y's. So what I always say is that the x's um, cannot be repeated. So for a function, the x's can't repeat. Okay. So if we look at these first two examples that I have written down, it just says, is the relation of function. So with number one, we're only really looking at the x's. That's all you care about. So if I look at the x's, we have -1, 2, 7, and 8. Those are all different, and so you would say, yes, that is a function. If you look at number two, if we look at the x coordinates, we have 0, 1, 0, and 7. Now, because we have these two x's that are 0 and they're the same, no, it is not a function. Okay, so we just looked at how to tell if a set of ordered pairs is a function. So sometimes instead of a set of ordered pairs, we're given a graph. So if that's the case, you use what's called the vertical line test. So it says that if a vertical line can be drawn, so vertical is straight up and down, so that it intersects a graph more than once, then it is not a function. So all we're going to do is take a vertical line, draw it straight through our graph, and if it touches it more than once, it's not a function. Otherwise, it's okay. So on number one, we have these 3 points, and if I draw a line straight up and down, pretend like that's straight, um, you notice that a single line does not touch that more than once. And so, yes, that is a function. So if we go to number two, if you draw a line through here, it's fine. It only touches it once. But if you draw a vertical line through this, it touches that in two different places. It touches it here and here. And so that tells me, no, it's not a function. That's not allowed to happen. So we look at number three. If you draw a vertical line through there, then it again touches it in two places, here and here. Okay. And so that tells you, no, it's not a function. If we look at number four, if we draw a vertical line through that, only touches it once there, once there, once there. No matter where you put a vertical line, it only touches it once. And so, yes, that is a function. Okay, the next thing we're going to look at is what's called function notation. So you can write a function. Let's say we have this line y equals 2x. Well, you can rewrite that with this f parentheses x. So what that means is f of x. You read it f of x. It's not f times x right here. You read that as f of x, and it's called a function of x. So basically, a function is if you put something in, you get something else out. So we're going to think about whatever is in the parentheses here. We're going to put that inside here, and we're going to get a value out. And so these first examples, give us this function g of x equals x squared minus 3, and then we're going to evaluate that. All that means is that if I have this g of 2 right here, I'm going to take the 2 and substitute it in for x. So you can see I've done that. I put it in here. So we had 2 squared minus 3, which is 4 minus 3, or 1. Once you do that, it turns out when you have a function and you evaluate it, of course what we're putting in is your x value. Okay, this is your x. What you get out is actually your y value. And so you can write that as an ordered pair. So we put 2 in. Let me get a different color. We put 2 in here, okay, and we got 1 out. And so that gives you your ordered pair. So we'll do the same thing with the next one. We're trying to find g of 0. All that does is tell me that I'm going to take 0 and put it in for x squared. Sorry, for x. So we have 0 squared minus 3. 0 squared is 0, minus 3 gives us negative 3. And then again, this 0 is your x, and what you get out is your y. And so we can write the ordered pair 0, negative 3. Same thing here for number, sorry, that was 3. I did it out of order. For number 2, we have g of negative 2. So I'm going to take negative 2, put it in for x. Make sure you put in parentheses. So negative 2 squared is 4. And then we do 4 minus the 3 is 1. So our x is negative 2. That's what we put in. And 1 is your y, what you got out. All right, the next thing in this is finding the domain of a function. So remember, domain is your x values. So when we're looking at a function in function notation or an equation, and we want to find the domain, we're trying to find all possible values of x. And so we did these a little bit with fractions before when we talked about rational functions and rational expressions. And so when you have a fraction, okay, so like number 1 is a fraction. Anytime you have a fraction, remember that we cannot divide by 0. So the bottom cannot equal 0. So to find the domain, the first thing that you do is take the bottom, set it equal to 0. So we do x minus 3 equals 0. I added 3 to both sides, and we got x is not equal to 3. So the domain there means that x can be anything except 3 because that would make it 0. Now, what I have written here is called set notation, which is totally fine for me, but MyMathLab does not like that. And so when you're doing these on MyMathLab, you're going to need to do what's called interval notation. Let me use a dark color so y'all can see that. Interval notation. So what that means is we've got to include every number except for 3. So the way you do that is you do parentheses, negative infinity, which is a sideways 8, and there's a symbol on MyMathLab. 2, the number you want to omit, which in this case was 3. Close the parentheses. You use a U shape for union. That's also a symbol in MyMathLab. Start the parentheses back. You're going to start back at 3. And then go to infinity with parentheses. And so that is your interval notation right here. All that means is that we're going from negative infinity to infinity, but we're skipping this number that is right here. So everything except that. So that's how you would put the answer in MyMathLab. So let's look at the next one. So if we look at number 2, we have this right here. F of x equals 2x plus 1. So when you have a line, the domain can be anything because there's nothing that we're dividing by 0, there's no square root, nothing like that. So if it's a line like this, just an x, there's no fraction or anything, then the domain is x is a real number or all real numbers, if you want to write it like that. But again, MyMathLab is going to want interval notation. So to do interval notation for this, if you want to include every number, you just do parentheses, negative infinity, comma, sorry, these are really hard to draw in here, positive infinity. What that means is it covers everything, okay? And then the same thing with number 3. If we look at number 3 here, we have an absolute value function. Absolute value can be anything, so it doesn't matter. Again, x is a real number. So to write that in interval notation for MyMathLab, you would just do negative infinity, comma, positive infinity, and close the parentheses, and that would be your answer. So sort of the shortcut for this class, this doesn't apply when you get to Math 112 and stuff, but the only problems you'll have in here that you have to worry about the domain are the fractions. So anything that has a fraction with an x in the denominator, you need to check the domain, see what would make the bottom 0. If it's anything else, it's going to be negative infinity to positive infinity or all real numbers, so you don't have to worry too much about that. All right, last thing in this section is sometimes the trickiest, and that is finding domain and range on a graph. So very important, when you're looking at a graph, remember that domain is your x's, and the x values run left to right. So when you're looking for the domain, you're going to look left to right. Okay, when you're looking for the range on a graph, range, remember, is your y's. That's your y-axis. It runs bottom to top. So you're going to look bottom to top. Okay. So what we're going to do on these, let's start with number 1. We're looking for the domain and range. So you are going to use interval notation like we did on those last problems, and we'll kind of walk through that. But for the domain, you're starting looking at your x's. So if we start with the domain, you're coming in from the left side and you're going to say, what am I going to touch first? Let's see. Okay, so we're coming in from the left side. Okay, and if I come in from the left side, the first X that I hit is right there. So I know that my domain is going to start with that X, which is -3. Since it's a point, you use a straight bracket like this, so we have -3, comma, and then we're going to see where we end. So I'm going to keep going, keep going, keep going, and the last point you hit, all the way to the right, is the 4. Again, it's always your x's, so we're going to use 4. So it stops at 4, so we're looking at where it starts and stops, so it stops at 4, and you use a bracket again because that's a point. Okay. Then we're going to do the same thing with the range. So the range is your y's, and you go bottom to top. So we're going to come in from the bottom, and if I start on the bottom of the graph, the first point I hit is this one, and the y value there is -1, and so that's a point, so I'm going to start with -1, comma, and then we're going to go to the top and see where is the highest point, where does it stop at the top. So if we go up, it stops right there, which the y is 5, so we're stopping at 5, okay, and close the bracket. All right, so let's look at the next example, number 2. So we're going to start again with the domain. So if I come in from the left side here, if I'm coming in from the left, okay, the first place this hits is this arrow right here, but that arrow really means that this graph goes on forever this way. So if we try to figure out what goes on forever that way, to the left, if something goes on forever, it goes on to infinity. Now, to the left side over here is negative infinity because it's negative x's. So we have negative infinity. Okay, parentheses always go on infinity. So we have parentheses negative infinity. And then we're going to look, where does it stop on the right side? So if we keep going here, all the way to the right, again, this arrow right here means that it keeps going. And so to the right is positive numbers. So keeps on going forever to the right, positive, it's positive infinity. Then if we do the range, okay, so we're going to come in from the bottom and see the first place it hits. So if we come in from the bottom, the first point it hits is that one. And that y, because it's the range, is -2. So we start with -2. It's a point, so use a bracket. And then we keep going up. If we go up, here and here, that's the top of what